Hello everyone and welcome to a new lecture. In this video we are going to talk about Wilson's theorem. So what is Wilson's theorem? Well, basically Wilson's theorem is a test to see whether a particular number which is greater than 1 is prime or not. The reason I did not talk about Wilson's theorem in the section on prime numbers, even though Wilson's theorem is related to prime numbers, is because in Wilson's theorem we have the idea of congruent, and at that time we hadn't talked about congruent. That's why I'm talking about Wilson's theorem at this point. So let's see what is Wilson's theorem. Basically, Wilson's theorem says that a natural number n that is greater than 1 is prime if and only if n minus 1 factorial is congruent to minus 1 mod n. If this condition holds true, then the number that you have, which has to be greater than 1, is prime. We haven't talked about factorials, so let me define what is factorial in case you don't know. The factorial of a positive integer n is the product of all the positive integers that are less than or equal to n. And just so you know, the notation for factorial is the exclamation mark. So suppose you have n equaling to 5. The factorial of 5 equals to 5 times 4 times 3 times 2 times 1. Okay? Suppose you have 10. The factorial of 10 is the product of all the positive integers that are less than or equal to 10. So it is 10 times, 9 times, 8 times, until you get to 1. So let's say we have n equaling to 27. The factorial of 27 equals to 27 times 26 times 25 times 24 times until you get to 2 times 1. So the factorial of a positive integer is the product of all the positive integers that are less than or equal to that particular number. So now you know what's factorial. Wilson's theorem says that a natural number n that is greater than 1 is prime if and only if n minus 1 factorial is congruent to minus 1 mod n. So let me give you a couple of examples. Suppose you have n equaling to 5. If you want to see whether n is prime or not using Wilson's theorem, all you have to do is to see if this particular formula holds true. So let's see if n minus 1 factorial, in this case n equals to 5, is congruent to minus 1 mod 5. So n minus 1 factorial equals to 5 minus 1 factorial, which is 4 factorial, which equals to 24, because 4 factorial is 4 times 3 times 2 times 1. 4 times 3 equals 12, 12 times 2 equals 24, 24 times 1 equals 24. So n factorial, in this case 5 minus 1 factorial, equals to 4 factorial, which equals to 24. And 24 mod 5, since our n right here is 5, 24 mod 5 equals to 4. And as you know, 4 equals to minus 1 mod 5. And if you don't know why 4 equals to minus 1 mod 5, we talked about how to find mod of a particular number, especially if you have a negative number. So if you have a negative number, all you do is you will add your n, in this case is 5, to the negative number until you reach a number which is between 0 and your n. Here is 5. So if you have minus 1, if you add n to it, which is 5, minus 1 plus 5 equals to 4. Therefore, 4 and minus 1 are equal in mod 5. As you can see it, 4 factorial, which equals to 24, equals to minus 1 mod 5. Therefore, by Wilson's theorem, n which equals to 5 has to be a prime number, and actually it is a prime number because the only divisors of 5 are 1 and 5 itself. So Wilson's theorem is a great tool or test to see whether a number that is greater than 1 is prime or not. So let me give you another example. Suppose we have n equaling to 6. So let's see if by Wilson's theorem we get n as a composite number or as a prime number. So n equal to 6, n minus 1 factorial equals to 5 factorial, which is 120, because 5 times 4 times 3 times 2 equals 120. And 120 mod 6 actually equals to 0. It does not equal to minus 1. Since 120 mod 6 equals to 0, therefore 6 is not a prime number. Actually, 6 is a composite number because the divisors of 6 are 1, 2, 3, and 6. It's not only 1 and 6 itself. So as you can see it, Wilson's theorem is a very powerful tool or test that will tell us whether a number that is greater than 1 is prime or not. Before we finish, you should know that there's a type of primes that are called Wilson primes. Wilson primes are a prime number p such that p squared divides p minus 1 factorial plus 1. And the only Wilson primes that we know of are 5, 13, and 563. If somehow you can find another prime number such that p squared divides p minus 1 factorial plus 1, then you have found another Wilson prime. And with this we come to the end of this lecture.